So today I want to present to you a FairSearch library that we implemented. And so what this does is it implements a set of algorithms, namely these two here, that are able to do rankings with certain fairness constraints. And why do we need that? This is because a lot of recent research has shown that machine learning algorithms and rankings in particular are prone to include biases, like pre-existing biases, social biases into their models, and therefore unfairly discriminating against certain social minorities. And with these two algorithms, we are able to mitigate this problem. And we wanted to make these algorithms readily available for a bigger community, and therefore we implemented this FairSearch library here. You can download the demo paper on arXiv and also from the proceedings. And I want to present to you what this library does a little bit. So we have these two algorithms implemented in different flavors, so to say. And I'm going to present to you the FAIR algorithm, so the first one of the two, which is a post-processing algorithm that re-ranks a given ranking subject to some fairness constraints. And we implemented the core algorithm in Java and in Python, and additionally also for Elasticsearch users. So you have a plugin for Elasticsearch and so you can use your underlying Elasticsearch environment and implement the algorithm directly there. And if you go into any of the packages, what you will see is the code, of course, but then we have a very nice README file, and I'm gonna go, because I was promising to do a little bit of live coding, but I'm gonna lead you through the README file a little bit. So here's how you install it. You basically just call pip install FairSearch core, that's it. Very easy. And so what the algorithm does is, if you're not very familiar, but the idea behind this is that you have a statistical significance test and you give it a certain minimum percentage called P, and that tells you I want to have at least this many percent of protected items throughout my ranking. And what this does then, it's calculating you such a table that tells you, in this position, I need at least 0 protected candidates, and in this position, I need at least 1 protected candidate, and so on. And then you have such a data structure that tells you how you have to re-rank your ranking such that it will obey to the fairness constraints, okay? And now let me show you what this does. Right, so here we see an unfair ranking. We have 20 items with a certain score. And we see that this item belongs to the non-protected group, and the items that have true here belong to the protected group. And we see that this ranking is unfair because it places all the protected items to the bottom of the list, and they will get less visibility. So if we perform this check, then it will return false, okay? Now, we call this re-rank function, we give it the unfair ranking, and it's gonna re-rank the ranking according to the table that we saw above. And because we saw that at a certain position, which is the 7th, I believe, we needed at least 1 protected candidate, the ranking is going to be reordered in order to meet that criterion. And if we recall this function, it's going to return true in this case. Okay, so that's a very brief introduction into this. If you have further questions, let me know by email. I have to leave, unfortunately.
Okay, thanks for your demo. It's great. The next paper